There we go. Number 1, worksheet 3. Again, it's a calculator worksheet, but I don't think number 1 needs any calculators because, I say that. We're going to get a quadratic, and I wonder if it factors. That could be the problem here. Particle moves along a horizontal line. Its position, right, S is position, is given by that thing, and we're in meters and seconds. Okay, so we're just going back and forth on a horizontal line. Find the instantaneous velocity at time t equals 2. They've given me position, and they want to know velocity. So, Jameson, what should I do first? Take the derivative of s, and I want to say that I'm doing that. So, s prime or ds dt, I want to somehow indicate that I'm taking a derivative. So, negative 3t squared plus 14t minus 14. At 2, so Brooke, what do I do about the at 2 part? Plug the 2 in. So v of 2, negative 3 times 2 squared plus 14 times 2 minus 14. And for now, I would box that and say that's my answer. Later, I may need to know if that's positive or negative, but I don't need that now.
We can do safe stops even if we have a calculator, right?
Yeah, yes, you can. I need to check on that. I think the answer is yes. Yeah. Part B, find the acceleration of the particle at time equals 2.
Wait, what's the thing that you draw at the top of the page? That's the arrows. What is it?
Oh, the little just short little cheat code there?
Yeah.
S to V to A. Position, velocity, acceleration. And so what does it take to move like down the page here?
Yeah. Well, one derivative.
Well, yeah, one derivative moves me one step. If I want to go all the way from position to acceleration, that would be a second derivative. So yeah, that's kind of the whole lesson of the last couple days. Start at position, take a derivative, get velocity, take a derivative, get acceleration. Speaking of Ambria, what should I do to find the acceleration of the particle?
Take this.
Okay, well, yes, take the second derivative of position, which is the same thing as the derivative of velocity. So, Lexi, what is the derivative of velocity?
Negative 6t plus 14.
So, Addie, if I want to find acceleration at time 2, what should I do? Plug 2 in for t. So negative 6 times 2 plus 14. That one I'm going to go ahead and do because I'm so smart like that. Negative 12 plus 14 is 2. It's not asking me for units, so I don't have to give units. But it would be meters per second squared. When is the particle at rest? Johnny, what's that mean, at rest?
When v equals 0.
Good. So when does v equal 0? So 0 equals negative 3t squared plus 14t minus 14. Okay, so here's where we run into the problem of, is it factorable or not? I have no idea. I am going to multiply through by negative 1, because that would make it easier to factor. 1 and 3. 1 and 14 would definitely not work. 2 and 7. Let's see, that'd be 6 and 7. That wouldn't do it. 21 and 2 won't do it. Okay, now I know why this is on the calculator page. Because, Jimmy, what's it going to take to solve this thing? If it won't factor? The quadratic formula. I I already changed the sign, so it's fine either way. You can use the original signs or the new signs. You should land at the same thing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's my favorite song. Let's see. I would probably check the discriminant first, because if that's negative, then this thing was definitely not even going to work. So let's figure out what that is. 196 minus 4 times 3 times 14 is 28. So if that's positive, that means I'm going to get 2 real answers. So 14 plus or minus square root 28 over 6. Oh, I said x equals. I should probably switch that to t to be more precise. And that's the exact answer. It does say your final answers must be to 3 decimal places. So, Jake, to your question about safe stops, that's accurate. That's a safe stop. But it did ask for 3 decimal places. So let's take this to 3 decimal places. 14 plus square root 28 over 6. 3.215 seconds. And then grab the same thing, but change the plus to a minus. 1.451 seconds. Okay, that's when it's at rest, because that's when velocity is 0. All right, there's more to this question though, McKenna. When is it moving to the right, to the left? Justify your answers. So how do I know when it's moving to the right or to the left? Okay. Which number line what variable am I looking at, or am I putting on this number line? Like, is it a position number line, a velocity number line, or an acceleration number line?
Oh, wait. At rest?
So velocity. So I'm looking for velocity. I know it's at rest at 1.45. I don't have to carry all the accuracy, because this is just like me working to see what's going on, so I don't have to carry 3 decimals all the way through here. No double roots, so I think the alternating rule would work. So I need to just check something. Check 0. That seems like an easy thing to check. So if I plug in 0, oh, here's where I better be careful. I changed the sign, so that I better not use the one I changed the sign on. It would probably be best to go back all the way to that original velocity equation. So v of 0 would be negative 14. And I feel like I've done enough of these. I feel confident in the alternating rule. There's nothing crazy about this one. There weren't any double roots. So I'm not going to check. I'm going to assume. Shouldn't even say assume. I know it's going to alternate. If you're nervous about that, well, then check one of the other intervals or check all 3 intervals. Okay, so I still need to answer the question here. Moving right. So Avery, what am I looking for? How do I know when it's moving right? When what's positive? Velocity. Okay, I knew exactly what she was talking about, but be careful saying it, especially when you're writing justifications. That happened a little bit on the last test. Don't ever say it, because you've got position, velocity, and acceleration, and when you say things like it's increasing, well, which one are we talking about here? Or it's positive. V is positive. That would be from 1.451 to 3.215. Moving left then would be when V is negative. I'm curious about how far left I start. But it said t greater than 0, so that means I'm moving left starting at 0 up to 1.451. I'm at rest at 1.451, so I'm not going to include it. But at time 0, this thing starts out right away moving to the left. So I'm going to include the 0. And then 3.215 out to infinity. Question D. Find the displacement of the particle. And almost always, after you find displacement, you're finding total distance. So I don't know, it's kind of helpful when we ask for both. I think it helps you remember that, oh, there's two separate things. Better make sure I get them correct. Ashlyn, how do I find displacement? Perfect. S of 2 minus S of 0. And if I had those defined somewhere, I could stop there, but I don't think I've found any of that stuff yet. So that's accurate, but that is not a safe stop. S of 2, I've got a calculator, so negative 8 plus 7 times 4 minus 28 plus 8. S of 2 is 0. S of 0 is 8. So that means I started at 8 and I ended at 0. So S of 2 minus S of 0, 0 minus 8 is negative 8. Started at 0, went backwards, so yeah, negative 8. Total distance, that one's kind of a pain because I've got to think about when I'm moving left and right and split things up, although I only have to go to 2 seconds. So what are the intervals I'd be looking at, Justin, to figure out if it's or what the total distance is?
Would you be looking at 3.215?
I only want to go to 2 seconds, though.
So 0 and 2?
So I do want to go 0 to 2, but there's something happening in between 0 and 2. So I need to go 0 to something, and then that something to 2.
1.45.
Yeah, with that 1.451, because it changes direction there. So I need to figure out where we are at 1.451, and then I can get those two distances and add them together. So S of 0 I've got, S of 2 I've got. I need S of 1.451. Let's see, do I have that in my... So there's 1.451. I'm just holding it in the calculator so I can be completely accurate here. When I plug it in, negative answer cubed, right? So I don't have to type it in, and I get all the accuracy when I do it this way. Negative answer cubed plus 7 times answer squared minus 14 times answer plus 8. So super accurate, certainly accurate to 3 decimals, negative 0.631. Negative 0.631. It didn't ask me for a motion diagram, so I don't have to do the motion diagram. Well, that might help. Let's see, I started at S of 0 is at 8, so there's time 0. At 1.451, I'm over here at negative 0.6. Again, I don't have to draw the picture, but it helps me make sense of what's going on here. So t equals 1.4, 1.45. So how far did I travel from t equals 0 to t equals 1.451? but not the negative.
Not negative. Oh.
I mean, I went backwards, but I just want distance. The fancy way to do that is with absolute value bars, S of 1.451 minus S of 0. That way you won't get a negative number. But if you're trying to understand what's going on, maybe you draw it out and then you can see what the answer is. 8.631. S of 2 was 0, so we're going to turn around and t equals 2, we're back at 0. So, Autumn, how far did I travel from 1.451 to time equals 2? How far is it from here to here? At 1.451, I was at negative 0.63. At time equals 2, I made it back to 0. So how far did we travel there? Thoughts? Autumn? How far is that traveling? Do you know? Okay. Somebody help out here? 0.631, because we were at negative 0.631 and we made it up to 0. So that's 0.631. Again, the fancier way to write it is absolute value of S of 2 minus S of 1.451. But I think it's easier to just kind of map it out and see the picture that that's 0.631. So 8.631 plus 0.631, 9.262. So yeah, total distance is always a harder question than displacement. Displacement's super easy. Where you end minus where you started. Total distance means you got to consider the changing of direction stuff in there. Right, the speed of the particle at time 1. Caden, what should I do to get the speed of the particle at time 1?
Just plug in 1 for ST.
Plug in 1 for where? Oh, that's a little misleading, I guess, because S isn't speed.
It's velocity.
S is position.
Just plug it into velocity.
So let's plug it into velocity. Got it highlighted up there. So negative 3 times 1 squared plus 14 minus 14. So V of 1 is negative 3 meters per second. That's not the right answer, though. What is speed? Think maybe back to physics. Speed versus velocity. Distance over time, but it's not an average speed, so I don't need that. Why is it just 3 meters per second? Because there's no direction. So the mathy way to say it is speed is the absolute value of velocity. The more concept way is what Dylan said, is like speed doesn't have direction, so speed would just be 3 meters per second. So it's an easy calculation question, but a little bit of a tricky concept question. All right, let's look at number 5.